out. You will want to have a calculator out today. Okay. 12.5, expected value. We're still talking probability, but we're using probability to find the expected value of something. So given that you have a probability of something happening, what does that make the expected value or possible outcome there? So to get us into the right mindset here, let's look at this first one. A company has 20 employees whose hourly wages are shown in the bar graph. An employee is chosen at random. What is the probability that his or her hourly wage is $12, $25, and $50? So we've got three probabilities we're going to find here. First probability we're finding is probability of $12. Thoughts? What do you guys think? 14 out of 20? Where's he getting the 14 from? It looks like that bar is 14 high. Where's the 20 coming from? Yeah, you've got, and they don't, oh, I guess they did tell you, didn't they? They do tell you. I'll be honest, I forgot they told us. And so I went with, okay, that bar is 14 high, this bar is 5 high, and this bar is 1 high. So I looked at 14 plus 5 plus 1 is 20. Good news is that checks with what's up top, right? 20 employees. So probability of earning $12 is 14 out of 20. What do you know about 14 out of 20? Both even. So divide by 2 and reduce this to 7/10. I have these as decimals, so 0.7 is what I have. So what's the probability your hourly wage is $25? What are we doing? 5? There's 5 people that make $25, so 5 out of 20. And what do we know about 5 out of 20? Reduce this to 1/4. As a decimal, that is 0.25. And what about the probability of having a $50 an hour wage? There's 1 employee in that situation out of 20. And what do you know about 1 out of 20? 0.05, right? 1/20th, 5%, so 0.05. Okay, so those are your probabilities. B, what is the mean hourly wage? Thoughts on the mean hourly wage? How?
I did 12 times 14 plus 25 times 5 plus 50, and that was like 343, and I did 20.
Is that making sense? If we're trying to find the mean hourly wage, we've got 20 employees here, yes? So we've got to add up all 20 employees' wages, which the long way, can we do 12 plus 12 plus 12 plus 12 plus 12 plus 12 14 times? Plus 25 plus 25 plus 25, and then add them all up? Yes. Or can we shortcut that and multiply? The fact that there are 14 people making $12 an hour plus 5 people making $25 an hour plus just 1 person making 50 out of 20. Okay. Do the math there. And you do get 343 on top. Dividing by 20 ends up being 17 and 1500ths, or 17 dollars and 15 cents. Okay, so that's your mean hourly wage. You could have added them all individually, but me personally, I'd lose count, so just easier to multiply and then add. And then C, what do you think? Is this mean a good description of the typical hourly wage at this company? Why or why not? I'm seeing heads shaking both ways, so.
Most people are making 12, and the people who aren't are making 10.
Okay.
So the 1%.
Okay. A lot of people are making 12. We do have some people making more, right? Does it make sense that this 17.15 is between these two then? The 25s are pulling it up a little bit. A lot of people make 12, so I'd be concerned if it got much higher. But it's closer to 12, right? So the fact that that 17.15 is between 12 and 25, closer to 12, where you see the majority of the employees, I personally think it's okay. I think it's good. Okay? It's never going to be perfect. Obviously, the fact that there are so many 12s, pulls it down, which is what we need it to do. Because if you tell me something up here by 25, that's not really going to be a good description, is it? Because not a lot of employees make 25. Okay, so I think it's probably as good as you're going to get. So is it a good description? I'm going to say yes. And I'm going to say it is between 12 and 25. And closer to 12. Okay. That is leading us into the idea of expected value, especially figuring that mean there is helping us to get ready to find some expected value. If you notice down here, expected value is the average outcome that will occur with many trials of an experiment. It is the sum of the value of each outcome multiplied by the probability of each outcome. Okay, so right there, the sum of the value of each outcome multiplied by the probability of each outcome. So keep that in mind as we look at this next example. Okay, the table shows data on sales for 1 month for each item on a restaurant menu. To estimate future profits, the owner evaluates the average profit from each meal. So when someone orders stew, they're getting 34 cents profit per serving, and the percent sold stew is 12% of what they sell. When someone orders soup, it's 41% profit per serving, and that's 7% of what they sell. Lasagna, 64 cents profit per serving, and that's 45% of what they sell. And then chili is 73 cents profit per serving, and that is 36% of their sales. Okay, so there's your information. Based on this data, what is the average profit that the owner can expect to make from each meal? Okay, so when it's saying the average profit they can expect to make from each meal, this is asking us for the expected value. Okay, expected value. Now, thoughts on how we find this? The sum of the value of each outcome multiplied by the probability of that outcome. I'm going to use E for expected value. That's what I think I tended to do throughout my notes. What do we know about stew? $0.34 profit on a serving. And what's the probability of them selling stew? 12%, right? And 12% as a decimal is 0.12. So we're going to be doing 34 cents times 12%. So 0.34 times 0.12 plus. Now the next one, the soup. What do we know about the soup? 41-cent profit times 7%, so 0.07. Continue along. Plus the lasagna, 64 cents profit times a probability of 0.45 plus chili profit of 73 cents times the probability of 0.36. That's how we're going to do expected value. Now, told you guys to have your calculators by your side for a reason, didn't I? Because at this point, you need to let the calculators do the talking. And the real test is, can you push all the buttons without making a mistake, right? I personally would just put this all in my calculator at once. It's doable, right? Number times number plus number times number plus. Your calculator's smart. It knows to do multiplication before addition. The other option is if you'd rather, you could do each of the 4 multiplications and then add them. To me, that's just more typing. Did we try it? Did we get something?
0.6203.
Yes. If you've hit all the right buttons, you got 0.6203, yes? Now, how should I express that answer here? 62 cents. Okay, this is the average profit that the owner can expect to make from each meal. So that is, if we round it appropriately, 62 cents per meal. I guess I should say that is 62 cents profit per meal. Okay, so that's the expected value. In other words, based on the profit made per item and the probability that that item is going to sell, putting it all together, average profit is going to be 62 cents. Now, B, what is the expected profit for the next 200 meals ordered? What?
120.
And why?
Take the 62 cents times the 200.
Okay, and I'll be honest, so it's the 62 cents. I will say that I actually took the full decimal, so the 0.6203, so before we rounded it. But regardless, it's taking that and multiplying by the 200 meals. When I take my 0.6203 and multiply it by 200 meals, I actually get $124.06. Okay? I think if you don't have the 03, you just get the $124, don't you? But that is the expected profit for the next 200 meals ordered. Surely restaurants make more than that per meal. I don't feel like that's very accurate. Can't say I've ever worked in the restaurant business, but it just doesn't seem very accurate to me. Now, let's take this problem and do some reasoning with it. What would happen to the expected value if fewer people ordered chili and more people ordered stew.
It would decrease
And why would it decrease?
because you make more profit on chili than stuff.
If fewer people are ordering chili, well, chili makes more profit, doesn't it? So if you have less people ordering chili, you've got less profit there. More people ordering stew, well, that doesn't make up for the lost chili profit, does it? Okay, so that's the type of reasoning. I mean, you could take some numbers and play around with it, but that's the idea behind it. So it would decrease, and that would be since chili makes a higher profit, but fewer people would be ordering it. So it would decrease. And I'm going to say since chili makes a higher profit, but fewer people would be ordering it. You write down a description that works for you. D, when you're ready, have you looked at it? Have you thought about it? Suppose the restaurant's profit on an order of stew increased by 5 cents and the profit on an order of chili decreased by 5 cents. How would these changes affect the expected profit per meal? Thinking logically. I know, always the key word there, thinking logically. Thoughts?
The money made on chili would decrease.
What?
The money made on chili would decrease. Or money made on stew would decrease.
Okay. Are we going to decrease again? Okay. Decreasing again, but for a different reason, right? Last time it was basically shifting the percents here, right? The amount stayed the same, but it would be fewer people ordering chili. So higher percent of stew sold, lower percent of chili sold. This time, we're not changing the percents, but taking 5 cents from chili and giving 5 cents to stew, right? Now, in an equal world, it wouldn't matter, right? If chili and stew were sold equally, it wouldn't matter if you moved the 5 cents over. But what's the catch here? More chili is sold, right? So that 5 cents you give to stew isn't going to be enough to offset less chili being sold. Okay, so again, it would decrease. Last time it was the expected value. This time it's the profit. Okay, I would find a description to write there. Let's see. On mine, I'd put more chili is sold, so an equal increase in stew would not be enough to offset chili. More chili is sold. So an equal increase in stew would not be enough to offset chili. Okay, get what you need there. Then we can turn the page. Okay, so that was expected value. What we can, in this case, expect the value to be based on the cost and a probability. This next section officially is find the expected payoff. So we're going to use the same idea, but here we're looking in a situation of fundraising event, charity events, things like that, okay? Who's, how much money are they going to make per situation here? So as we look at the first one, a charity is considering a fundraising event in which donors will pay $1 to spin the wheel 3 times. And so you see the situation here. You have this wheel, 1, 2, 3, 4, 5, 6. $1 to spin the wheel 3 times. And basically the game is, they're calling it even threes. You spin 3 times, you get 3 even numbers, you win. And you're going to win an item that is worth $4. Okay? So it's going to cost you, as a person, $1 to pay. And then the fundraiser, so that's you're adding to their money. If you win, you're going to get a $4 item. Right? If you lose, you don't win, you're just out that dollar. So, our question is, what is the expected payoff for the charity each game? Okay, so as we look at that, each time someone plays, basically on average, what's the charity going to do? How much are they bringing in per person? So you do want to pay attention to, this one is asking expected payoff for the charity. Let's start by looking at the game. What do we know about this wheel that we're spinning? Okay, chance of being even and odd are the same. I mean, if we do the basics here, there's 2, 4, 6. There's 3 evens, yes, out of 6 pieces. So just in general, when you spin the wheel, the probability of getting an even is 3/6, which is 1/2, right? That's for one spin of the wheel. Now, what do you have to win the game? 3 spins, all landing on evens. So as we talk about this situation, let's talk about what is the probability of getting 3 evens. You're spinning a wheel, so probably the first time you spin is 1/2. Probably the second time you spin is 1/2. Probably the third time you spin is 1/2. What do we do with those 1/2s? We multiply them. 1/2 times 1/2 times 1/2 is 1/8. Okay. So, let's see. I think I'm going to look at this of the probability of winning the game versus not winning the game. And then we'll turn this into the charity. Okay. And there's a couple different ways I can look at this. So I'm trying to decide best way to go about this. So what is the probability? And let's see. I'm going to call the person a donor. Probability, the donor wins the $4 prize. And I have a direction I'm heading with this, if you just hang with me. What is the probability the donor wins a $4 prize? So if they pay $1, they play the game, what's the probability they win? That is the 1/8, yes? Now, okay, what is the probability the donor doesn't win? Are you guys with them? Probability donor does not win. Why 7/8? Yeah, because if you have a 1/8 chance of winning, what's the chance of not winning? And that is your 7/8, right? You can think of it as, that's what I thought. On my notes, I wrote it down as 1 minus 1/8. Because it's like 100% chance minus the 1/8 chance, and so that is 7/8. Am I being logical here? Following? Because here's the deal. For the expected payoff, this question is asking for the expected payoff for the charity. So now we've got to turn this around and think in terms of the charity. Okay? How much could the charity win or lose? I shouldn't say win or lose. Earn or lose based on what happens, based on what the person winning does. So what are the options that they could do? The charity could gain. What did you say? Okay, they could gain money or lose money. If the charity gains money, how much are they going to gain on one person? $1, yes? So what is the probability that the charity gains $1? That's the 7/8, right? Because if I, as the donor, lose, I have a 7/8 chance of losing. So the charity has a 7/8 chance of getting $1. What's the other alternative? The charity can either make $1 off of me, or how could they lose 3?
Because you gain $1 for each time they spin the wheel, but if they get 3, then
Are you guys following your thinking there? I pay $1, so they get my dollar no matter I win or lose. If I win, they're paying me a $4 prize, yes? So the charity is out $3 on me then. So the other option is the probability of that they lose $3, and that probability of losing $3 is 1/8, because that's the probability I win. And if it helps, you can write underneath here, $4 minus $1, yes? That's how we could lose $3. Now, okay, expected value, or in this case, it is expected payoff, yes? With the expected payoff, we're going to put all this information together, kind of like what we were doing on the front side. On the last problem, it was the profit per meal times the probability it happens, right? Plus the next profit per meal and the probability it happens. So, what are the options? They could gain $1, and the chance of them gaining $1 is 7/8. Plus, what else they could do? They could lose $3, and that chance is 1/8. So we're going to multiply those pieces together. It's going to be the $1 times its probability of happening is 7/8, plus the negative $3 times its probability of happening, which is 1/8. That's how you're going to find your expected payoff. Okay? Yeah. In my brain, it's logical. Is it logical? Am I making it logical to you guys? Okay? I'm trying here. So, 1 times 7/8 is 7/8. I left this in fractions because it's easy. Negative 3 times 1/8. Well, 3 is a fraction is 3 over 1. 3 over 1 times 1 over 8 is 3/8. 7/8 minus 3/8 is 4/8. My brain says 4/8 is 1/2. But what am I supposed to be finding here? I'm supposed to be finding expected payoff, right? Yep. Money. So what is this as money? 50 cents.
Per person that does it?
Yes. That's exactly what I was going to ask this. So what is that 50 cents? This is, on average, for each person that plays the game, the charity, and remember this was the expected payoff for the charity is going to gain 50 cents. So are they making money? Which is the whole point, right? They're making 50 cents per game every time you pay $1 per game because they have a $4 prize, right? Okay. Now, what is the expected payoff for the person making the donation? So this question is, what is the expected payoff for the charity? This is the expected payoff for the person making the donation.
$2.50.
Think on expected payoff, though, is on average.
Just
Okay. Think logically here, and note I didn't really leave workspace. At least in my brain, it works this way. If the charity's making 50 cents for every person on average, what are we doing?
The rest of
We're just losing, on average,
50
cents. Okay. Now, I did just have a thought that I could have worked this out. Oh my goodness, I can't write here. Still forgot the numbers. Could we take the situation from previous and reverse it? I didn't think about doing that. In my brain, it was just the opposite. But the idea that, yeah.
You could do
Yeah.
1 times 7 eighths plus 3 times 1/8. You get,
Does that work?
yeah.
So if you want a formula, I didn't think about that way. I just thought, okay, it's kind of the opposite. But I would be, instead of gaining $1, I'm automatically losing $1, right? So you could think of it as negative $1. Well, if I just pay $1 and I lose, that is a 7/8 chance. Plus, if I win, I'm not really winning $4 though. I'm winning 4 minus the one I paid. So $3, and my chance of winning is 1/8. Does that proof help you out there? I had some confused looks on you guys weren't believing me, I could tell. So there's your proof. Take what we did earlier and just reverse it. Okay? Okay, where are we at on time? Am I going to get into this one and get caught? Or can we get through it? Huh?
Got caught last time.
I tend to get caught a lot, don't
Yeah.
I?
Yeah.
But there's 4 minutes of class left. That's a lot of time.
That could be 4 minutes of confusion tomorrow.
It is. Okay. I will take the smart route out today, this time, and not get us caught in the middle. So we will pick up tomorrow talking about Margaret, which will give us another time to talk about expected payoff.